Hey guys, this is Krister from Visual Components. Normally I work as a sales manager in Scandinavia. Today I will show you how you can get going with Visual Components, meaning how can I go from nothing to something in a quite short period of time. We will focus now on making a quick machine tending concept with some conveyors, some machines, maybe a little bit of storage, potentially an MR, and let's see how we can build that together. One of the coolest things with the software is obviously our library of components. So we are soon reaching 4,000 different components. And one of the more typical components I would use in a demo would be a conveyor from Visual Components. So I simply double click this one and we'll see it will load to the 3D world. We can now see how it is represented in here. On the right hand side, I can see that we have presets. And here I can basically customize which industry vertical I am targeting for this concept. Is it lab? Is it electronics? Is it some heavy woods or metal? But for now, we will leave it as a belt. I can customize, for example, width, length, height, and so on. I can also change, for example, the material of the actual belt to be something else. We could change the structure material to reflect what we have in the factory, like that. If I now take another conveyor from the library, we can see that it looks like the original. At the moment, I have the plug and play tool selected, and then when I bring it closer, we see this arrow indicating that I can actually connect these two together. And when I do that, I can inherit the settings from the previous one. That is pretty sweet. Now let's say I want to create a gap like this, and I would like to align these two. I can do it in multiple ways. Let's say old-fashioned way would be to fiddle around with the parameters here, where it is located in the world. But I will choose the move tool instead. I grab hold of the y-axis, hold down my shift key, and I can align it with the previous conveyor. So now I know these are aligned. I could also double check here the y parameter in the world. It is the same. Okay, now let's say we take a curved conveyor, drag and drop it. Looks the same, plug and play, inherit, go back to default tab. And what is cool here is that in every field in Visual Components where we have numbers, we can actually do math. So I can simply add 90 and we can see how that is evaluated. I could even multiply this with half, for example, I come back to 90 degrees. Pretty nice. I can also go to the advanced tab and start customize things. We could remove a support, for example. We could also change, for example, the position where the supports are located, add something different if it fits better to my concept. Okay, we take one more of these, put it over here, and one more over here. We can again use the move tool now with the x-axis, shift, and I align these two. We will make a little bit bigger space here, so this will be where our operator will be later. Now we want some products for our conveyor line. So we go to the flow components, we find a feeder here. A feeder in our world means a component that can create the raw material for our line. And of course, you can create any type of geometry that you would like. The default one that comes is a cylinder. If I check under the product creator, I can see how this is created and what it is called. So we can see that right now we are in a single feed mode. We could feed batches. We could read in some Excel table, which indicates when a product should be created and which one. And we can even use mathematical distributions, such as normal or square or something like this, or rectangular, it's called, right? Anyway, and we can also limit how many products we will create. So at the moment, it is set to 100,000. Okay, we'll come back to this product a little bit later. But for now, it looks like this. So we have the cylinder, and we can see that it automatically just gets pushed on the conveyor line. So we actually have our first simulation model already. This means that if I go in and manipulate the speed of the conveyor, we can see how that impacts the whole simulation model. The behavior becomes different. If we bring it back to 200, we can see that they start to accelerate away. So this is pretty sweet. So that already sets us apart from any CAD software. It would be very tedious to create an animation for this. But this is a simulation world, so everything comes with certain behaviors, all right? Okay, let's drop in some more stuff. So we go to Machines Library. We can see that we have some different machines. Of course, it would be nice to have more, But hey, it is in the hands of the CNC machine manufacturers. But at least we have some here, right? So we could take this guy from Haas. It's a turn center. I will position it over here. This comes also with a pre-built behavior, so we can interact with doors and things like this already. Doors and panels. It should have some spindle inside, fingers that can go in and out and stuff like this. Okay, very cool. Put it over there. And let's bring in a robot. And in Visual Components, you can teach a robot in many different ways. What we're going to do now is we focus on concept. That means that we have a limited amount of time. We want to get as much as possible in the shortest amount of time. So we'll use a robot transport controller to basically program the robot for us. So all we need is some kind of spatial understanding, figuring out distances and stuff like this. And the software can help us with that. So we bring that, and then we're going to find a robot. And on the robot side, we are very strong. I haven't calculated this in a long time, but I would guess we have something like 70 different robot brands. You find here ABB, KUKA, Yaskawa, Fanuc, Universal Robots, Omron, anything you ever heard of, and many more likely. For now, I will use an AV robot, and I know something like 2600 should give me a good size for this layout. So I take this one that has a 1.85 meter reach, drag and drop, plug and play, and we can see now that if I move around the pedestal or the transport controller, the robot follows it. This means that the robot is now a child of this guy. Same thing goes if we now go to the tools library and find a tool. We can, for example, head on to Shunk, and we can use, for example, this 125 tool that has 3 fingers, a 3-finger gripper, snap it on the robot. If the pedestal now moves, robot moves and gripper moves. Pretty sweet. If the robot would move, only the gripper would follow, because the pedestal is the parent of the robot, so the parent do not care what the child is doing. Okay, let's go in and we customize this gripper. Basically, we know that the product that we gotta pick is 100 millimeter big. So we are looking for this min opening parameter. So we'll simply add there 40 millimeters. Then we can also add 40 millimeters on this overall width. We have now customized our fingers. Also inside the gripper, we have this tool center point position. It's basically where the robot will grasp the product. And we can use this depth parameter to adjust where the top face of the product will end up when we have picked it. Let's say over here. In the background now, where we connected this, inside it there's a little script. You could open it if you're a power user, otherwise you probably do not mind. But what it does under the hood is that it actually connects signals between the robot. So now the robot can use these signals to open and close the gripper. And it does that all automatically, nothing I as a user needs to care about. So how would we do this? So to create an actual flow, we need to use some flow components. And what we're going to use is our from conveyor process. So I want to go from here, and I want to go to the machine, and then I want to use a to conveyor process to come back to the conveyor line afterwards. So these comes prepped with some statements, but you can of course create your own ones. You can do whatever you want, but these kind of solves the necessary stuff that you typically have. Let's say we do this flow without considering the robot first. We come in here, we now change the process context. We can see here that we have the product we've been talking about. The product is in a flow. Our task now is to say, how does all the products in this flow get around in our layout? So we hit the flow button, and we want to come to this position, and we want to go into the machine, and we want to come out from the machine. We can see that we have generated now a transportation network in the 3D world. And down here in the process flow editor, we basically see all the processes that the product needs to go through to complete the flow. If we check one of these transportation links, we can see that they have a speed. This is basic, or a time. This is the time it takes for a product to go from here to here. And this is a good way to test the flow. We can also see here that I have yellow text. It basically indicates that we're running in virtual time. Let's switch to real-time mode so we understand what is the time. When product hits the sensor, we can call it, the product will start to move into the machine. And this movement will now take exactly 10 seconds. And when it arrives in the machine, we'll start to run its program. So now the machine will start to move the tailstock and the spindle and stuff like that, and start to produce the product. And of course the machine has properties as well. For example, process time and failures that you can customize. For now, process time is 10 seconds on the machine, and it also has some set down and set up when we're opening and closing the doors. If we want to study the program of the machine, we can hit this ball, and we can see now that currently we are executing the custom machine process. That is basically a small script that runs inside this machine, so it's able to produce products with different sizes. But we could have done all the program also directly in here. And we do so by combining these process statements in specific orders. So here we can do quite complex programs with simply configuring statements. Okay, too deep for now. So we have seen this flow working without any robot or human and so on. So this is interesting already in the first phase of a project to see, is it feasible at all? We can see this buffer is now full, meaning that we are ordering material too often, for example, to our line. But let's say we want to integrate the robot into our flow now. So we simply take the transport controller, we bring the robot somewhere where we think is a realistic position, maybe there. We can of course check this kind of workspaces and stuff like this as well. But typically, I mean, that you have in CAD systems, quite boring. Let's skip that. We simply test it instead. Select the robot, select where it should be used, change transport controller, hit play, and here we go. We can now see that the robot is utilizing the tool and it is picking and placing. We could of course create some process here to let the products not collide with each other and stuff like this. Would be very possible as well. We could even utilize something from here. For example, conveyor utility, picking zone. We should be able to integrate this quite neatly over here, I would imagine. Let's see if this works out as intended. First product should be let through. The second one, if there is a product here, should be stopped by the green arrow. Let's see on the second part. So this guy stopped here until the robot has picked this part. And that is something you would normally do in real life, right? You would single out the products so that the robot can pick them without having any collisions. Looks very nice. Okay, let's continue this. So we want to have a manual workstation over here. So let's go ahead, manual workstations, and like this, and we grab it to there. And what we want to do now, let's bring in some more stuff as well, and we can integrate it later. We take from warehousing, warehouse shelf, drag and drop, put it over here. This we can also customize, changing the size of the shelves, how many bays and so on. So if I change this to 3 or 5, or we can do it 10, for example, and we could decrease the height to 2. We could go, for example, here and change the type to be pick to light. Okay, and we can see how this whole thing changes. Pretty neat. Okay, so let's say we have this guy over there. Now we need to have some more processes in here to complete our flow. So we'll go back to flow components, and I will take a from conveyor process, and I put it over there. And we have a to conveyor process, put it over here. I could of course now zoom in and actually copy paste this, because we're gonna need one more. And I put it over here. Okay, and we take a sync process. Basically we could say this is the end of our simulation model, put it here on the back side. And what I would normally do is to integrate also some statistics already now, so we can start to get some data from our line. We have many different components here that helps us to gather statistics. One of my favorites is of course the time tracking point, which I made many years ago. This will allow us to get cycle time and lead time for all the products that passes this. Now what we need to be aware of is if we have processes with the same names as we have here, from and from, system will believe these are parallel processes. But we are making a sequential flow, so these need to have unique names You can either change them manually by clicking here and writing something, or as I like to do, if I'm doing kind of repetitive stuff, I just make a small macro or add-on that makes it for me. So now, for example, by clicking this button, we can see these change to 2, 2, and 3, and so on. So I got that basically for free. I didn't need to do it manually. Okay, coming back to the flow, what are we going to do now? We're going to see what's going to happen next. So we go from here to the table, come back through the cycle time calculator or time tracking point to this buffer and then to the output. So we have now created a transportation network in the 3D world, and in parallel we get the process sequence down here. So all the processes we need to go through. If we simply run this with the default settings, we'll see the product comes through the machine, will come to the table, rest there for a while, fly through the storage, and get ordered automatically to the output. So this would be the default scenario without me changing anything. Let's say we now want to incorporate a human operator over here. So we have these locations. Those are the pick locations, pick and place locations. So let's leave them as is for now. So we will see how we can do it wrong, and then we fix it later. So we're gonna have a resource. We can pick different resources depending on what we're gonna do. I'll take the human operator now. If we were gonna do some ergonomic studies, we should use our humanoid. He has better descriptions of the links, and we can connect him to the Reva Rula charts and see what's going on. But for now, that's out of scope for this quick demo. So we take here a transport controller because we're going to transport something, and we're going to find the human transport controller. We can also take the mobile robot transport controller. We will use it later on, put it on the floor, and I put it over here. Now we basically select this guy and we say connect all resources, and these are now paired. If we would have more than one operator and they would be doing different things in the 3D world, we can have many controllers, and then we can use our interfaces to connect specific operators to specific controllers. But for now, we have a simple layout like this. So we simply select where this operator should be used. And when we hit play now, we will see that the operator will walk here, pick the part, go there, place it there. We can see also that the operator is currently not working at the workstation. So let's open the process and we can see what is happening here. Get a product in, we change the state to busy, we have a delay, we're in blocked state, and we get it out. So let's delete this delay, we go to the statements, and from here we select the work statement instead. And we can say which controller we should use. Yeah, we'll put human transport controller. We can open the process time. We can select from here distribution. For example, normal distribution, because operators are not working with a constant time, right? Maybe it's changing over the day a little bit. So we get some differences here. Then we zoom in, we select these two processes, and I will use the properties here and cycle through until I find the right place. Okay, it's the left side. And I accidentally shifted this, so let's bring it back. Okay, now we play again, and we should hopefully see that the operator will go to the right side of the conveyor line, or the side I want to pick the part. And this pick and place time, that is something we can also control inside individual links. So right now it is pick time 5 and 5, but we can see that these are grayed out. If I want to customize it on link level, I select this one. For now, it is inherited from the controller. So I can, on the controller side, go into link defaults, and I can override it and say that, hey, I want to just pick and place for 2 seconds. And we can see now that if we run this layout again, the operator will pick and place much quicker from the conveyor and to the table. Walk over there, and we pick a product, and we can see how the operator brings it to the table, and it's much faster. Now she will start to dance with her hands. And that is our current visualization to show that Anna is busy and she can't do anything else. We can see the next product arrives. She doesn't care about it because she's busy over here. After those 13 to 17 seconds, we are done. We place our part, and we can go and pick the next one. And so it goes. Okay, let's say we want to put an AMR over here. How do we do that? We go to our AMR library, and that is called Mobile Robots in Our World. We can find our favorites from here. Maybe I will go for the Mir robot and the Mir 250, for example. I like that one. And we can connect it. So we connect it here. Connect all resources, select it, and use it. And now I will already have a functioning mobile robot. But we will pick in the wrong location and we don't have any conveyor on top and so on. So let's first see how it looks out of the box without us doing anything, and let's fix it. Product comes there. Mobile robot will start to drive. Slide into the side here. Not very pretty, but it works. So from a functional perspective, it is okay. But it doesn't look very realistic. We are not super happy with this outcome. So how can we fix it? We can take, for example, one of these conveyors that we had here. Just copy paste it. I'll remove this process that is on top. And we need to find some kind of measurement. How big is this mobile robot? So I will try to measure from some point to some other point here. Okay, so it's likely like 800 long. Take my conveyor, change the length, 800. I'll use my attach command. So basically these guys are normally here in Home tab, but I am annoyed by having to switch context. So what I can do is that I can add these to quick access toolbar instead. So then they end up over here and I can use them from any context. So now I'll use the attach and I will attach the conveyor to the mobile robot. This basically means that now the mobile robot is the parent of my conveyor. Cool. So select this guy. We can reset parent coordinate system to 0. Okay, use my move command again, align the set axis to top. Okay, and we remember this was 800 long, so we can simply remove here in x-axis 400, and it's now on top. We see that the conveyor is currently flying 300 millimeters, so we should basically, or not flying, it's standing on top of the mobile robot. So we should remove 300 here from the height, and that means that this height should now match the height of this guy. Okay, and last step, we need to adjust that these transport locations that we have here ends up on top of the conveyor line. So we'll go to transport tab, change to 700, they appear on the top, and we go over here. So I'm using the shift or control right click to get this center of interest. So I can jump there and rotate around that point. The setting in the backstage, how you want to control this. That's the way I just drag now x-axis, this jumps to the end, and we want to move this over here. So just scroll through, then you don't need to think. Half of 800 is still 400. So this should be the perfect position. We play again. We'll see here how basically when we get a product out, mobile robot will now drive to a much better position. So this can be customized, how far away we have our approach position. Now it is some 1.5 meters away. Go there, rotate, and drive forward. It's all parametric, so we could set it behind a modeling tab to be OmniMove or whatever we want. But for this one, it should just simply drive forward and reverse as little as possible. Okay, pretty cool stuff. We can also see here if we select the human transport controller, for example, we can see navigation mesh, basically all the obstacles it has found. We can hit this show obstacles and we see this yellow and red squares. Basically, yellow, we are allowed to walk inside whenever we are picking and placing. Otherwise, we should stay outside of yellow. Red, we are never allowed to go into. Okay, last steps now for this demo, or a couple more steps, I think. Let's generate statistics out of this. I just hit this button. Okay. I go back to Home tab. Of course, I now should add this to Quick Access Toolbar, and I could now have accessed also statistics from the Process tab. Then I didn't need to change back to the Home. So let's click it from there instead. We get now our statistics window. We can here, it's very flexible. We can create any type of data that we want. and we can look at any numeric value that we have. But what is cool with this component, it is basically generating this for us, so we don't need to do it on our own. And we just run the simulation through and we start to get data. So we get now the cycle time and lead time for this layout. And we can see that the lead time is still growing, but they are converging. And it basically means that we have somewhere buffers that are filling up. And those buffers, of course, are these conveyors. So when these buffers are full and a product has been maximum amount of time in both, then the lead times should converge. If I now wanted to add more data to this, I can simply hit change layout and we could look at something more. For example, we change to this guy and we have now one more block over here, and we could look at utilization of our equipment. So we can take the robot controller, the machine, human operator, work table, mobile robot, and we hit utilization here. And if we select it again, right hand side, we could choose here, or sorry, over here, that we want to have cumulative data, so not interval statistics. I think that is covered in some tutorial if you want to know what is the difference and so on. But here we can now follow utilizations, and as we probably would have predicted, our mobile robot and the human operator is really busy. And our robot and machine will flatline at some point when the buffers are full very soon, and it will start to dive. But even though utilization of the robot and machine is going down, we will have more or less a constant throughput because our mobile robot and human is working really full stop. Now we can see also that the mobile robot is continuing at 100%, but actually the output buffer here is now also full. So the operator will also start to decline her utilization. Okay, pretty cool. So one thing I know that system integrators are struggling with quite often is to build safety fence around their layouts. And we have a nice component for this. So we go to Facilities Factory, and we find here Fence and Wall Builder, drag and drop. And now we can choose what we're going to do. We're going to make fences. We can also change walls and so on. But fences for now. And we basically think a little bit where do we want it. Let's say we want to make a fence from here. And we simply go around the robot like this. We can even make angled fences if we wanted to. Of course, this fence makes no sense because we should normally make a fence around the machine, right? But let's say we make it like this, just so you see how complex we can make it. And we hit populate components, and there we go. We have our fence, just as we basically drew it. And we can select one of these, and we could customize, for example, how it looks like. But we can also customize, for example, stand heights to allow the product to pass underneath. Pretty sweet. We can also use the same component now to create indoor walls. If we want to make a nice office space for the operator, for example. So she's in this office, cubicle or whatever. We populate the components and we get it there. We could add there, for example, the possibility to have a door, and we could add windows on these. Pretty nice. We remove this and we go and we take a factory building now, and we will put basically this cell inside a factory. If you have a point cloud, you can also use that. If you have your own 2D drawing, you can import it. If you have your own factory model, you can of course also import that. But I don't have it, so I have this quite nice looking building. I can also customize here, for example, to choose a shorter width in this case, and we can see that the whole hall kind of rebuilds. We could remove the roof to allow light inside if we don't have the time to make light sources. We can position our layout somewhere inside it. Now we can see that we have some pillars, columns straight through our line. Let's put them there. And now what is nice to do, so we can see that this is already looking pretty awesome. But we can use our Blender add-on now to generate a nice looking picture out of this. I just change the samples. I can change the light setup to be machine shop, for example, and we hit render. And what happens now is that we are exporting the whole scene If we have recorded animations, the animations as well to Blender. And in the background, it will now start to render a nice looking layout out of this, or a nice looking picture for now. So we can see that this takes a couple of seconds, but that's all right. We're just making a picture. If we would be making a video, it would do this basically once and then this for every sample. So let's see here. Here we go. Here we now have an awesome render of our layout. We did it in full HD, so we can't really zoom that much, but we can see how the light goes through and it looks pretty amazing. If you want to see more examples what you can do with visual components, please head over also to my LinkedIn channel. I have hundreds of videos there showing how to do different things. All right, thanks a lot for watching and have a beautiful day.